extensions. All of you know that Postgres has a lot of extensions, and we use a lot of extensions because always there is a positive bias. So extensions are good to have in the system, irrespective whether it is used or not. But that comes with the alongside the all the pros, there are cons also that no one talks about. And when I was experiencing all these troubles, I started preparing some of the content. And later I realized other people also working on the same line. So I would like to thank some of the work by Marcos Lord, Frank Passion, because they done a lot of research in this area. And the common perceptions about extensions is extensions add features and makes Postgres really cool, just like that element. Uh, and we suspect that the Postgres built-in features are not affected by adding extensions. So everything works as normal, and all the Postgres documentation works as it is. Uh, there is no considerable performance degradation, and extensions won't consume so much of resources. Yeah, we expect some impact, but not much. These are our expectations. But those expectations may not be always true. There is a flip side for that. So, as of now, I think we have around 430 extensions in PG extensions network. So, it's a big list of extensions. And if you consider extensions which are not listed in PGXN, we have thousands of. So around 1,200 extensions are there with doing different things. Today morning we were discussing. There are extensions for even playing chess. So that is the level of extensions people are creating and innovating around, because getting all these features into the Postgres core is difficult, and that may hurt many people. So even in Postgres community, we have country modules as extensions, because every feature may not be required. It may not be worth to add that overhead in the system. So please visit that link. You'll get the complete list of extensions available. And generally, the type of extensions are classified into access methods, aggregate functions, the extensions which is implementing new data type like CG vector, which Vibor was mentioning, dictionaries, foreign data wrappers, procedure, additional new procedure languages, spatial, geospatial stuff, and every extension is not same, so the complexity varies. So simple things like adding a new function could be an extension, but there could be extensions going very deep in Postgres. Like best example is Citus. Citus completely changes the entire Postgres. Once you have Citus extension installed, the Postgres is no longer a Postgres. It's something. It's a different beast altogether. And there are extensions which need to be loaded into the execution, like using shared preload libraries or session preload libraries, kind of. So those extensions put uses hooks to inject the execution within the Postgres. So when we have a different function getting executed, the behavior of the Postgres may not be the same. Underlying thing is different. So once we have that extension mask, the capabilities changes and the behavior also changes. And in the right hands, it could add, it could be result in a positive way. But there are cases where it really hurts us back. So we need to remember that once we have that memory loaded into memory, that will be there in the every process. So every process getting forked we have those functions loaded, and it is those complex extensions are implemented as C hooks in the system, and Postgres has huge set of areas starting from SQL plan till the storage. The hooks can be there everywhere. So throughout the PostgreSQL code, there are a lot of places where you can have the hooks. So all these extensions could be using a lot of that features. And Postgres Postgres don't restrict any extension not to do certain things. Wherever hooks are allowed, it can override anything, and it can intercept critical operational things, query planning, execution, client authentication, and transaction management. Everything can be interrupted by extension. Okay, and so yeah, in more than talking about the theories and concepts, um, if I can show you a quick demo, that will be registering your mind proper way. So let me have a quick demo. I won't take more than a couple of more than 1 minute. Oops. Like with multiple screens is a difficult task. Okay. Is it visible? Yeah. So I have small insert statement, and it generally runs very fast. So basically, I'm running a SQL script. It deletes some 720 rows and inserts another 720 rows. Irrespective how many times I execute, the actual response is in milliseconds. The insert, so because it's a bare minimum Postgres. What happens if I add few extensions? So those are the very common extensions. And oh, sorry. Okay. Okay. So those are some of the very common extensions, widely used extensions. Nothing very complex. And to get those extensions into effect, let me restart the Postgres because it's a shared preload libraries. And please see that the actual we just loaded the extensions into memory, but extensions are not created. The SQL interface is not created. What will happen if I execute the same insert statement again? It's running. It's running, and I am not expecting that to complete anytime soon. it is so much of overhead that those extensions are creating. So I just thought of showing this demo because people have that perception that extensions are okay. It's a comparable overhead is there, but only more than 10%, 15%. It can be so heavy on the system based on the specific use cases. And the QA won't be able to capture all these edge cases. There are so many edge cases where extensions can cause this. And we can't blame them for that. So extensions are good. It has features, but it causes drag for the entire Postgres. Better disconnect it when it is not used. Remove it from shared payload libraries. Yeah, so this is not something new. Somebody from Alibaba Cloud reported it in way back. So the very common extensions like PG such statements can cause very considerable performance degradation. Here is a PG bench execution. So the with extension and without extension, almost 3 times, so 300 times percentage say difference. So the PG such statement is something everyone uses, but it's very common, and that can cause severe performance degradation. Here is another LinkedIn post by Nikolai. So he was experimenting with what is the limit the Postgres can achieve. So he hit on 3 million TPS, something really amazing number. But the moment PG start statement is there, see the difference. So this is nothing unknown to everyone, but we are not commonly talking about this extra overhead comes in the system by adding the extensions. And not just performance degradation. There is a very detailed paper by Marcos Lott and Abigail. So that's a multi-page detailed study of the extensions, and it analyzes different aspects of the overhead and the troubles the extensions can make. So the title itself is the best anarchy in database. That is a level of damage it can cause. In that paper, they classify the type of extensions and the major extensions existing in different categories. So there are 408 extensions for user-defined functions. So the number of extensions available in Postgres communities varies across the functionality. And the second table shows what are the features Postgres will allow you to modify and what. Yeah, and the paper link is available here. So if you are interested after this presentation, please download that paper and look at that. It's very detailed, so they reduce my work. Yeah. So in the major areas of concern is Postgres is very flexible for its extension ecosystem. So being very flexible comes with this problem. There is no safety mechanism in place. What is the level the extensions can go up to? It's highly permissive. Postgres allows to access even low-level APIs. And the second set of trouble, extensions can interfere each other. Suppose you have two extensions loaded into memory. So both are competing for so there are common points of executions, and they can interfere in a very bad way. And the extension loading order also matters. So the order in which the extensions get loaded. So if you are having multiple extensions mentioned in the shared preload libraries, the order matters. And the behavior become unpredictable if you accidentally change the order. And there is no sandboxing for execution, which I think database people know this. Then compatibility and interoperability issues. Yeah, this is a supplement to that. And and there is no built-in mechanism for interoperability. So if you look at the Linux ecosystem, so the package management, everything makes sure that there is some level of safety is in place. But we don't have that level of safety mechanism when we have extensions. Um, so I don't know whether you remember olden days where Microsoft had all these ELL health trouble, the dependency issues. Was using, uh, it was causing big trouble, and the hook chain is very fragile. And security risk, as I mentioned, Postgres has no restriction anywhere. Extension can access complete data passing through the system, the storage. Uh, Extensions can bypass PostgreSQL's permission systems. Uh, it can read user credentials. If extensions are not developed or tested, audited properly, that's a major challenge. The safety in Postgres comes into the wide auditing happening. Postgres community is worldwide community. Every line of code is getting audited. So in Postgres community, if you participate in discussion, you can see how many replies come for each discussion. But when it comes to extensions, that level of auditing is not happening. So extensions are generally maintained by very few people, like one or two people maintaining the extensions, and we allow their code to override the PostgreSQL's built-in functions. So that is a dangerous area. Be aware about that. But yeah, so if you are using the config modules, there is almost no risk because it's maintained by Postgres community. And extensions can link external libraries. So this you already know because PostGIS has so many libraries linked externally. And these external libraries can have serious security risks. So you might have heard about the problem of XZ library, the compression library. Someone manipulated that development and injected some backdoors. So I would like to repeat that statement. A chain is as strong as its weakest link. So if you are linking external library, you are introducing security problem in your system. And this is another area. The APIs won't be stable, and there is no way to ensure that the APIs safety in extensions. So please visit the Marcos Notes presentation. He gives detailed explanation of what are the ways the APIs can give you trouble. So, the APIs changes from version to version in extension, and the SQL interface for that APIs may not be compatible. And there are areas where end user can manipulate that SQL interface such a way that you can inject malicious code. So and the extensions upgrade become tricky because of the API incompatibility. And I was watching yesterday's many of the talks about the training sessions. So there were many mentions about many extensions, and some of the extensions mentioned in this those training sessions were actually very complex, like a thinking plan that, that that takes a lot of code from Postgres and re-implements. And personally, I look at many of the customer user environments. Daily I review around 5 to 10 cases. So I see. Actually, I've taken these the shared preload libraries from a real end user. This is a list of extensions preloaded into the database because they are not aware about the damage they might cause. And when we have multiple extensions listed like this, the extensions which is loaded in the last will be called first, because that is a function which is going to be called by the Postgres. And the extension can change the hooks. So one extension can call the previous extension's hook, and that can form a hook chain of hooks function calls, and the end result is unpredictable. So what will happen if multiple functions are called one after another? And like Marcos Load says, you are lucky if it just causes some crashes, but you are unlucky if that causes some kind of data corruption. And that paper they mentioned goes very deep in analysis. What are the level of the extensions can conflict each other? So they analyze only pairs. So they took pairs of extensions and compared whether they can incorporate properly. So they analyzed a few hundreds of extensions. Yeah, so and 16.8% of those extensions can't work together. And if you look at the most complex extensions, many of them can't interoperate properly. And all the tests are the red areas, the test failures. You need to understand these are combination of two extensions combination, but we can combine a big list of extensions as we saw, and very often we blame QA for not doing these kind of tests, but we need to understand it is nearly impossible to achieve that quality because the extensions uses the PG regress that has its own limitation in ensuring the quality because it is basically doing a string comparison at the end result. That is not sufficient to ensure a extension compatibility. And we have hundreds of extensions. So the permutations and combinations of all the extensions become so huge. So suppose we have only 100 extensions existing. So we need to understand that there will be 100 factorial combinations can be formed. Okay. I may not be good in maths, but the number is 10 to power of 157. So can you imagine this number? We know the Avogadro number is 10 to power of 23. And this think about the size, this is not even, say, if you consider the entire atoms in this observable universe, it will come to a order of 10 to 80. So all the combinations no one can test. It's impossible. And operational challenges. And even today morning somebody was saying the extensions becomes biggest hurdle when you try to upgrade Postgres. So generally Postgres upgrades are very smooth from even older versions like a 9.1 or 9 to the latest one. Because the file format is not changing it anytime recently. It is stable, but the extensions can cause all the damage. So because of some of the extensions like PostgreSQL, people will end up upgrading from version to version, so one after another. And there are uh, architectural lockings because of the extensions are not very actively maintained. So recently I came across this. Say the Postgres core has improved a lot, but say for example, the logical replication protocol has a version like a version up to 4 now, but some of the extensions are yet to catch up. So those are failing, and we have a lot of cases where extensions cause outages, and in fact, that is the major cause of outage I observed recently. It causes memory leak, segmentation fault, and Postgres crashes. And in summary, uh, so extensions add custom code throughout PostgreSQL and alter the PostgreSQL behavior. It can call any internal Postgres function and modify global variables, very risky. And it can conflict with the other extensions in the system. And it can crash the database. It can corrupt memory and storage. And it can leak memory, break PostgreSQL features, cause severe performance degradation as we really saw in the screen. It can cause security problems at multiple levels, and it can cause vendor lock-ins. It can result in unmaintainable system if the extension maintainer is no longer very active in development. Upgrade failures can link external libraries and can create additional process in the backend. And there are extensions doing network communication. Be careful about that. Yeah. So basically, the ecosystem, the power which Postgres gives to extensions is so huge that it can literally screw up everything. Be careful about that. And recommendations: always have a critical view of extensions used, especially those implements a lot of hooks. Those which are not part of contribute modules are more safer. Uh, and look at the popularity of extensions, how widely it is used. Avoid rarely used extensions and extensions which are maintained only by one or two maintainers. Please avoid that. Remove extensions that are not regularly used. Say, always review your payload libraries and critically assess that and to remove things from there. And involve your security team to audit the code, audit the extension code, because that is a place where a lot of things could be hiding. Okay, and I have a couple of presentation links. Uh, there is already somebody done a very detailed analysis, but this presentation will be more towards the extension developers, how what are the security problems can introduce. But yeah, that's a good reference. Thank you all.
More questions? Mentioned about auditing, right? In case of like we go for a cloud provider like Microsoft AWS, they give the extensions as well. They are not doing the auditing, or they are just simply giving.
Yeah, so it's a good question. So when we use managed services by cloud providers, we don't have the ability to control any of those things. We already gave the control to them, so now the only option is to blame them.
I mean, the question is like they give the security checks when they give that managed service to the cloud.
So I believe most of the cloud providers do auditing, but yeah. So the level of auditing they do, I am not sure about. You may have to check with the specific cloud vendors. what are the security auditing they are doing. And I am aware about the problem. So many of the cloud vendors will prefix this shared tree node like this. You don't have control. Yeah, so that's a area of concern, and the performance degradation which we observe and widely reported.
Second question on the performance side. How exactly the PG stack is everyone is using it as a production. Everyone generally uses the because of the statistics and all. But if in case instead research statements are becoming slow because of the PG stats extension, then how we can manage that?
Yeah. So the question is, the PG stat statements is widely used. So if that itself is becoming a problem, what will you? Yeah. So Postgres community is aware about that. That is why the PG stat statement is not integrated into the Postgres core. It is kept as a separate extension. So it's your choice to have it. So it's opting. We choose to have it to monitor. So, and you need to understand, there is nothing free. Everything comes with a cost. So the 10 to 15% cost needs to be paid for the monitoring. Monitoring comes with a cost. So, but the point is, there are edge cases even in there which can cause much more severe degradation. So the monitoring has the moment, say, for example, if you have if you recruit a security person at your home to safeguard your family, the security person himself can become a security threat. So you are allowing somebody inside. So yeah, be careful about that.
Yeah, people do actually audit code. They make sure that these are safe. So if you're using cloud service providers, if you're using cloud service providers extensions, they do audit it because it's a big responsibility of maintaining customer data on the service, right? So they do audit that, and in case some extensions like on demand, they make it available on the platform too. But they do also mention that there's a caution that use it over based on whatever your need is, and they will not be responsible for that. So if you're using your extensions pretty much vetted by the cloud service providers or vendor, go for it because you know whom to be, because you know who's gonna actually pay you back in case something goes wrong. But if you're just going to pick up any random extension, it's going to be very dangerous for you. Be conscious on that front.
I mean, the way I look at it, some of these cloud guys say that we are SOC 2 compliant, we are PCI DSS compliant, we are HIPAA compliant, right? All of these compliances come at a cost that Jobin is also saying. So pick the right extension, right set of cloud services, and look at it.